Alrighty, welcome back. This week we're doing Graptolites, very fantastic fossils, interesting fossils. This class that I'm teaching here at Chico State is invertebrate paleontology. What are Graptolites? They're kind of invertebrates, but kind of not invertebrates because they actually had something going down their back. In fact, we think about them as the phylum Hemichordata. And so they are an extinct group. They're hemichordates. Technically, they're in the class Pterobranchia, subclass Graptolithinia, and there's several orders of them. But here's, again, if you're new to this whole series I'm doing on invertebrate paleontology, I'm a paleontologist, but I'm a paleontologist straight out of geology. Very little biology in my background. Sorry. I think of things as the way a geologist who does Earth's history thinks of fossils. So that's what you're going to get. And there's loads of other resources out there to learn more about the biology of graptolites. So let's cut to the chase. As a geologist, I think the value of graptolites is they are amazing, amazing for telling time. They're some of the best biostratigraphic fossils for the Paleozoic. They go back to the Cambrian where they're kind of encrusters. But then when I think about them in the Ordovician on through, they were kind of planktonic forms. They floated in the water. And the benefit of being planktonic means that you're just sort of at the whims of the ocean currents. You're drifting, you're feeding on things. They looked like seaweed. Seaweed feeds on light because seaweed is an algae. Graptolites are totally animals. They're colonial animals that we'll get to, but they were floating. The benefit of being a floater is when you die, to a geologist, you fall wherever you fall. And so they're not so limited to facies as some other like great fossils like corals are. And so we find them in deep water deposits. They can be really common throughout the early Paleozoic. And again, when you find them, because they, as a group, they evolved rapidly, they went extinct rapidly, they were all over the place. And even though they're often always, I mean, nearly always preserved as flat compressions or like carbonizations on the rock, as we'll see, they're really easy to identify. And so they're awesome for doing biostratigraphy. So what is a graptolite? Let me show you. All right, well, I'll show you in a minute that there's many, many different kinds of forms of graptolites, but if we break them down to their basic form and look at them up close, it's a colonial animal. And what they leave in the rock record is this kind of branching structure. Sometimes I've even seen that called a branch, but technically the branch that they're on is called a stipe, and it ends at the where it began is the sicula, and along that stipe are the growth chambers where the animals lived because they're colonial, so it's animals, and that's a theca, or plural is theca. Isn't that cool the way I added an e to make it plural? Well, let's zoom in and see what the little critters looked like. All right, here's a geologist teaching biology. Now, we got to remember that these things are extinct. There's no living example of them, but what are you gonna do? It's best you can do. So we will look at them in terms of there's some that are preserved in 3 dimensions and a few that have these beautiful Lagerstätten deposits, fossil Lagerstätten, where you can see the soft parts preserved. So what we think is it's colonial. There's loads of these theca along a stipe, and inside one of those theca is one organism. Basically, they have a mouth, a gut, anus. It's an animal. It's got these arms with tentacles. Where have we seen that before? Yes, in pretty much a bunch of things that try to grab stuff out of the water because it's a great way to be a filter feeder, or at least a suspension feeder, and pulling things out of the water. And so these arms with their tentacles move the food down to the mouth. It gets digested. And then at this tail end of the animal, we see this thing called a stolon. And if we saw a lot of animals in this colonial form, those stolon would be connected. And that's how they all communicate and feed each other and live as a very successful floating planktonic animal. Again, I think if you swam in the Ordovician, it would have looked like masses of seaweed, but they were animals. And how they're often preserved is as carbon impressions on rock. Ooh, it's working good. And so this is a sample here. And if I just kind of flip it in the light a little bit, when the right angle of the light hits that carbon, you can see they look like little saw blades, little teethy saw blades. Pretty typical and often in dark shales because, again, they live in the water column. They sink into the deep ocean. The deep ocean's kind of yucky, reducing a little bit. And so we tend to get organic rich shales. Here's another example. Again, you can see how dense this particular slab is. And when I found graptolites, and this one's from New York, is you take the shales and split them and peel them. And you know, you're in the field splitting a lot of shales, but if you're patient, you can get some really nice ones. Here's some examples from white rock. This is from the Ordovician in southern Minnesota near Rochester. And you can see these, in this case, the graptolites are preserved as dark lines in the rock. What's really cool about these, and I don't think I can show this to you, maybe with this one, is if you get it on the side, nah, it's not going to show well. These are preserved in 3 dimensions. I said earlier, here's one more block from Minnesota. And when I split this rock from the quarry, you can see these graptolites in 3D. In fact, here's an amazing example. I didn't collect this, I got it. It's preserved in a slide in glass, and somebody digested the rock. There's no way I'm gonna do it. And they pulled the graptolite out, and so you get it in 3 dimensions. They are nearly always preserved flat, but occasionally you can get them in 3 dimensions and get them out of the rocks. Cool, but even the flat ones are great for identifying them. So simple structure, it can get complicated. The little critters are gone. How do you actually differentiate graptolites? All righty, for the record, remember these are hemichordates and they're terebranchs. So I suppose since they're within terebranchs, there's probably, you could argue that there is some living representative, at least a cousin to these ancient ones in the modern terebranchs, like Rataplura, I can't remember the name of it. Rataplura, we'll go with it. Anyways, but among the Graptolithina, there are 4 orders, at least from the reading that I've done, there's 4 orders. I'll be honest though, as a geologist, these first 2, I don't remember ever seeing those in the rock record. I'm not a specialist. I hit rocks. If I find the fossils, I find the real experts in them, and then I learn about them in the process of trying to understand the rocks. These last 2, though, the Dendroidea and the Graptoloidea, are the common ones. Now, Dendroidea are well, let's start with Graptoloidea. Graptoloidea, the bottom one here, those really are planktonic forms. They tend to not have many stipes, just a few of them, is how I think about them. And Dendroidea have many stipes. They're more bush-like and complicated. I was just trying to look, see if I had one here, but I don't, so I'll have to use magic and put it up on the screen. But the Dendroidea, because they're so bushy, people think that they were more benthic and they lived on the seabed. So what do you do with graptoloids? Again, if you're in the field, particularly if you're in deep water, although they can be found in shallow water too, if you're splitting rocks, particularly in the earlier part of the Paleozoic, like Ordovician through Devonian, I'd say, and you're finding these graptoloids, they are worth drawing, taking a photo, getting some if it's legal to collect, because if you don't really know the age of the rock, they are amazing for dating the rocks. And as far as knowing the parts, there aren't too many parts, but you can still describe them. Have fun with your graptolites.